So now it's time to start a discussion about subclasses. So often you want to represent only a fixed set of possibilities. So a web request can either succeed or it can fail. A user can be a standard user or a pro user. And in those cases, you may be thinking now that you can use enum classes, but enum classes have some limitations. And let's see why you should use instead subclasses. So let's type main. I'm going to create an enum class here, call it result. And let's put curly braces. Let's type here success. And error. Now, the problem with this is that we cannot encode more information here. So let's say that I want to define here a non-resolvable error and a resolvable error, and I cannot do that here. So if I type here x.exception, I cannot do that because the types that we define here cannot have properties, so you cannot define this here. And for that we need to use subclasses. And to use the subclass, we just type subclass. I'm going to call it result. It's going to have a parameter called val message. It's going to be of type string. And you can define your classes which are going to inherit from the subclass either outside the subclass. So you can type here class, let's say success, and let's type here message of type string, and we can inherit from the subclass. So you can type here result message, or you can copy this and you can define it inside the enum class. So you can have it as an necessary class. So I'm going to type another class here called error. I'm going to define the parameter here. Actually, not that is the parameter. Message. And I'm going to define the parameter here, message. I'm going to inherit from the result, from the results class. I'm going to pass that parameter here to the parent class. Now, I'm going to define a function down here called get data fun get data, and it's going to have a parameter called result. Going to be of type result, and here we're going to define a when statement. So we type when and we type result, and now is the interesting part. Now if you hover over this underline over when, it says when expression must be exhaustive, add necessary is error, comma, is success branches, or else branch instead. So in other words, what it's saying here by to have the when statement exhaustive, is what it's saying in other words is that it needs to cover all the possibilities. So both possibilities that we have here. And you can type yourself this, or you can click on here, click on this right bulb, and you can click here add the remaining branches. And as you can see, it's added the remaining branch. So you add is result.error and is result.success, and those are exhaustive. Those are the only two possibilities which are possible. So here I'm going to type result. Let's define a function inside the subclass. So I'm going to type here fun show message. It's going to have a print line which is going to say result $, message. So, and now I'm gonna put dot show message, and also here result dot show message. And now this is exhaustive, because now we covered all the possibilities which are inside which are as a consequence of the fact that our classes are inheriting from the seal class. So if I add here an else branch, so if I put here else, as you'll see, this is going to be redundant because we covered all the possibilities, and the compilers know this, and this can be very useful in some scenarios. So if I put curly braces, as you can see, this is grayed out because it's redundant, because it knows that we covered all the possibilities, and the possibilities are only those two, result.error and result.success. So if I type here now val success, let's type success equals result, it should be O2 yes there, equals result dot success. Let's type success here. Let's press Ctrl D. Let's call this error. Result. Let's change this to error. So this is how you create instances of the nested classes. Let's call this failed. Now let's type here get data, down here get data, and let's pass success, and let's run our code. Now as you'll see the message result success. So we get result success in the output. So if I change now this to error, you'll see that it says result error because it's executing this branch. So if I run this, you get result failed. Now the interesting part here is if I add here another possibility. So if I type here class progress and I type message string inheriting from result, let's pass the message parameter to the superclass, to the parent class. Now what we have, because our class is a sealed class, what we have here is that the when is underlined and is trying to say something to us. It's saying that when expression must be exhaustive, add necessary is progress. So it knows that there is another possibility for our result in which it can be. Therefore, you need to add that possibility. Otherwise, I'm going to show you this error, and if you try to compile this code, I'm going to throw an error. So what you can do here is we can type here is result to make it exhaustive, so to cover all the possibility, result dot progress. Let's put the arrow, result dot show message. And now if I create here another val, let's call this progress equals to result dot progress, and let's define for the parameter progress here. Now if I change this to progress, now you'll see in the output result progress. So we get result progress because now this branch is true. But if I delete all of those, look what happens. If I click here where you have those this underline, it says add else branch. So when expression must be exhaustive, so it means that it needs to cover all the possibilities. Add necessary is error, is progress, and is success. So if we click here on more actions, And if you click here on add remaining branches, it knows that those are all the possibilities on which our result can be, and it automatically generated the check for us. And we only just need to type here result.show message, and that's all. And with enums you don't have this auto-generated code for you, because result.show message, let's type here and I'm gonna explain immediately. So with an enum, if you add another so if you have an enum class, I can delete the code now here but I'm gonna keep the code as it is. And because all the subclasses of a seal class are known by the compiler can fill all the possible cases automatically for you. So if I declare this arrow class as a seal class, and I declare two classes inside here called, let's say, class resolvable error, or recoverable error, and it's gonna have a parameter called exception. It's gonna be of type exception, this one, and we're gonna extend from our error seal class, not this one, this one, and we're gonna pass the message parameter. And I'm gonna declare another class, non-recoverable, and it's gonna have an exception. So this is more powerful than enums, because you can have all those properties, and you can have subtypes and all of this, and with enums we cannot do this. So let's extend from error. Let's pass the message, and now I need to delete this because you cannot instantiate the sealed class. So let's delete this. Now if I delete this now from here, look what happens. I have an underline, and it says when expression must be exhaustive, so it must cover all possible cases that exist for this seal class. As necessary is not recoverable or is recoverable branches. So if I click on this and I click on this bulb and I click here add remaining branches, as you can see, it added all the possible cases, so all the possible cases that we define inside our seal class for us automatically. And we just type here result dot show message, again here result dot show message. And you cannot have this behavior with the non-class. So this is why seal classes are more powerful, because you can have subclasses, you can have more information on the classes, so you can have exceptions passed to them and so on. So this is our discussion about seal classes, and see you in the next video.